17%. How about this one? 25%. 15.8%. 9.8. Good job. Okay, so what we did there is we identified the mass of the whole compound, and then what amount was contributed by the hydrogen. All right, so this one is the most mass of hydrogen. True? All right, excellent.
Hold on. So after you get the total weight of the compound,
Yeah.
then what do you get the total?
So you got 12, 13, 14, 15, 16. So this is the total mass. And you take 4, the mass that's from the hydrogen, over 16 times 100. That'll give us our 25%. The mass by the hydrogen over the mass total gives us our mass percent. How about weak acids? Do we know the 2 weak acids here? The first one and the last one. Very good. Okay? How are we going to know that? You just got to know it. All right? Unfortunately, there's 7 strong acids. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. Those are our strong acids that we need to know. Here's the weak acid up here. Okay? So you need to know the strong acids. Okay, the net ionic equation for this reaction. Net ionic equation. What are the products of this reaction? Sodium, fluoride, and what else? Water. That's right, sodium, fluoride, and water. Very good. Now, let's find the ionic equation. The ionic equation, if the ionic compound is soluble in water, or if it's a strong acid, the ionic compound or the strong acid is written as ion. Is this an ionic compound that's soluble in water? Rule 1. Yes, sodiums are always soluble. So, sodium ion, hydroxide ion, NaF. Is that one going to ionize in water?
Yes.
Yep. Na, fluoride ion, water. Is that going to be broken up? No, that's a molecular compound. How about HF? Is that going to be broken up? No, because why? It's not an ionic compound, it's an acid, and it's not a strong acid. So it's a weak acid.
So the H doesn't really count in
It doesn't count, that's right. It doesn't count up there like that. It will only dissociate if it's a strong acid. Okay? So, finding the net ionic equation here, we'll be getting rid of what? What could we get rid of? What are our spectator ions? Just the sodium. Leaving behind HF, the hydroxide ion, F minus, and water. Okay? That would be our net ionic equation for this reaction. Okay? So here's one here. How many grams of sodium phosphate would be needed to make 50 milliliters of a 0.2 molar solution? How many grams of sodium phosphate would be needed to make 50 milliliters of a 0.2 molar solution? Does everybody understand this question? Can you read that crazy writing? How many grams of sodium phosphate, you gotta know what sodium phosphate looks like, right? Would be needed to make a 50 milliliters of a 0.2 molar solution.
Okay, did anybody get this one? How many grams of sodium phosphate will be needed to make 50 milliliters of a 0.2 molar solution? Anybody have any ideas with that one? 4.7 grams? Anybody else get an answer? Anybody else still working on it? Who wants more time to work on it? Okay. Anybody need more time on this one? Did anybody else get a different number?
I got the same one, but I got different decimal spots, I don't know.
Oh, yeah?
I did that wrong.
You did it wrong, you think?
Yeah, I think it's
11.8 now? Should I just add another vote or? All right, let's figure it out, okay? What goes to the right of the equal sign? Grams of sodium phosphate, true? Let's try to be really descriptive on our units so that it can help us out as much as possible. Na3PO4, is that critical? Absolutely, we need to know what sodium phosphate looks like. We want 0.2 moles of Na3PO4 for every what? Well, this big M, what does that big M mean? For every 1 liter. That's right. And then we only want 0.05 liters of it. Right? So now we can take moles to grams. How many grams are there per mole of that? Let me guess. Oh, 163? That wasn't my guess. Anybody else double check that? What's the molar mass of sodium phosphate? 163.94. Good. Grams per mole. All right, 0.2 times 0.05 times 163.94. Anybody get a value? What'd you get? 1.63. Okay, 1.63 grams. Very good. What's the molarity of nitrate ion when 10 grams of calcium nitrate is dissolved in 1.2 liters of solution? Molarity of nitrate ion when 10 grams of calcium nitrate is dissolved in 1.2 liters of solution. Want to work on that one for a little bit? That's a good question. That's critical, right? How can we find out what calcium nitrate looks like? It looks like it's going to have calcium, right? And what does the nitrate ion look like? NO3. And now we need to know the charge on these two, right? So we know calcium's +2 because of its location on the periodic table. Nitrate is a -1. So it looks like this is going to be CaNO3 2. Right? Name of it is calcium nitrate, right? Molar mass of calcium nitrate. Calcium is row 2, 164.
Calcium nitrate has a molar mass of 164.088 grams per mole.
Okay? Very important. Good job. Notice that. What are the units that we want to the right of our equal sign? So moles of what? What are we looking for? Nitrate, NO3. NO3 minus per liter of solution. Just because that was the question. What's the molarity of nitrate? Yeah. So if we take 10 grams of calcium nitrate, 10 grams of calcium nitrate, we're dissolving it in 1.2 liters. I can put the 1.2 liters down here, right? That's all right. That's my liters of solution down there. Good job. All I have to do now is go from grams of calcium nitrate to moles of calcium nitrate. Where do I want to go after that? After I'm in moles of calcium nitrate, what do I want to do? Moles of nitrate. Let's see, this is 164. How am I going to go from moles of calcium nitrate to moles of nitrate? Do you know how many moles of nitrate there are in 1 unit of calcium nitrate? There's 2. There's 2 moles of nitrate for every 1 mole of calcium nitrate. Right? So if I have 1 of these, how many nitrates are there? There's 2 of them. Okay? 2 moles of nitrate. So I should be done here. I'm in, when I cancel out moles of calcium nitrate, grams of calcium nitrate, I'm in moles of nitrate for liters of solution. That's what I wanted to get here. So, no, it's going to be 10 times 2 divided by 1.2 divided by 164. Right? What did you get?
0.102.
Molar nitrate ion. Is that right? Anybody else want to double check that? Okay, we got that. Good. Again, we took our 10 grams, multiplied it by 2, divided by 1.2, divided by 164, and that should give us our 0.102 molar nitrate ion. Is that the molarity of calcium nitrate? No, it's right. The molarity of nitrate ion is twice as much as the molarity of calcium nitrate.
So the molarity of calcium nitrate would be like
Half that, 0.0501. Or 0.0501. I think that's right.
Does it matter if the liter of 2 liters, does it have to be underneath the calcium nitrate?
You mean, can it be over here?
Yeah.
Yeah, it could be over there. That's
It
fine.
doesn't matter where you put that, as long as it's in there.
As long as it's down here, because this is liters of solution that we're after, right? Okay, very good. How about this crazy one here? What will the compound be that forms when the XYZ ion combines with the calcium ion? If sodium combines with the XYZ ion in the following manner. Okay, we need to know what calcium XYZ. What will the chemical formula calcium XYZ look like? So think about that one for a little bit, write it down and see if you can get it. That's right, CaXYZ. Very good. So what did this tell us about the XYZ ion here? Yeah, so what we're gleaning from this is that there's 2 sodiums necessary for each XYZ ion. So that means that this must have a -2 charge. So that's what we were trying to get out of that information, right? And so then it's going to be in a 1-to-1 ratio with calcium because calcium has a +2 charge. Okay, any questions about that? So, looking for some names here. So, write a name down for these compounds here. I'll give you time to do that instead of just talking about them, because if we just write about them, you'll think that you know when you don't really know. So write down a name, commit yourself to an answer. Did you get some names down for these ones? These 4 compounds? These aren't minus signs, they look like minus signs. What are their names for these 4 compounds here? All right, selenium tetrafluoride. Okay. Phosphorus triiodide. Okay. Yeah. Scandium 3 iodide. Good. This one here. Carbon tetrabromide. Very good. We had 3 molecular compounds and an ionic compound, right? Excellent. How about this one? How many milliliters of 0.2 molar calcium hydroxide would be needed to react with 20 milliliters of 0.5 molar HCl? Hi.
Hello.
Okay, did anybody get that one yet? Far left? Anybody get an answer here? No? No? Anybody want more time on it, or you want to talk about it? Talk about it? Ready? Okay, so right of the equal sign. Yeah, calcium hydroxide. So, milliliters of calcium hydroxide. Milliliters of calcium hydroxide. Important to recognize that it's CaOH2. That's what we're looking for. What can we start with? So I'm tempted to start with this 0.2 moles per liter. 0.2 moles of what per liter of solution? Calcium hydroxide. Now, if you started with that, did anybody try starting with that? Okay, the problem is, what do we want on top here? What is this? This is a volume of calcium hydroxide. And here we have the volume of calcium hydroxide on the bottom, right? So that's okay to start with, but we want to flip it. For every liter, there's 0.2 moles of calcium hydroxide. So for every 1 liter of the calcium hydroxide solution, there's 0.2 moles of calcium hydroxide. Well, this is information in terms of liter, right? So if we want to get those liters into milliliters, there's 1,000 milliliters in 1 liter of solution, right? Okay, so right now we have our units in milliliters of solution. Are we done though? No, sorry. Now we're in, what did I do? Now we're in milliliters. For every 1,000 milliliters, there's 0.2 moles of calcium hydroxide. But we need to get rid of these 0.2 moles of calcium hydroxide, right? So moles of calcium hydroxide needs to go up here. What can go down here? We're reacting that with what? Hydrochloric acid, right? Moles of HCl. Here we need, and we're in the land of the moles, what is it we need though? Yeah, we need the stoichiometry. We need to have the equation. So we need to know how these two things react. How do they react? Calcium hydroxide with HCl. What are my products? Water and calcium chloride, like that. I need 2 chlorides there, right? That's critical because, well, this would have told us as well, but we need to see that this needs to be balanced. Right? You want to talk about how we knew that was balancing? Or? How do we know there's 2 chloride ions? Because calcium has a +2 charge and the chloride has a -1 charge. All right, so that tells us that for every mole of calcium hydroxide in the reaction, 2 moles of HCl are going to be consumed. Right? And now I can get rid of moles of HCl using this 0.5 molar HCl. There's 0.5 moles of HCl for every 1 liter of solution that we combine it with. This is liters of the HCl solution. Now if I stop, let's see, I got liters of calcium hydroxide going to milliliters. So that top is done. I got moles of calcium hydroxide canceling out there. Moles of HCl canceling out there. Now I got liters of HCl solution. So if I stop right now, I have milliliters of the calcium hydroxide solution over liters of hydrochloric acid solution. But that's not where I want to stop, right? I need to get rid of these liters of HCl solution. Can I do it? How? Like this one here, 20 mils, right? The 20 mils. So that's 20 mils of the HCl solution, which is 0.02 liters, 0.02 liters. So 1, 0.1, 0.5, 0.02 divided by 0.2 and 2. So, anybody get an answer in their calculator with that one? Did you get it? No? Okay. Let's see, we got 1, 0.1, 0.5, 0.02. Multiply all those values together, divide by 0.2, 2, yeah, just 0.2 and 2. 2.5 milliliters of calcium hydroxide solution. Is that what you got? Awesome. Is that what you got too, or no?
So you timed it all by the top and then divide by 1?
Everything on top, you just say this times this times this times this times this, divided by this, divided by that, divided by that, divided by that.
Is it a 0.1 or 1,000?
Which one? This one here? That's 1,000. You're right. Sorry about that.
Yes.
Okay, good. Okay. Anybody else want to talk about this one? You got 2.5? How about back there? Did you get anything? You got 25 mils? You got 25 as well? Oh, another one got 25? Oh no, let's do it again. Where's my calculator? I got my lame calculator. So we got 1,000 times 0.5 times 0.02 divided by 0.2 divided by 2. Yeah, 25. Okay. Excellent. How about this one? How many sig figs are in this answer? 4. I got you. No, this is a trap. See, these are always trap questions to make sure you know how to do sig figs in addition and subtraction. Right? So when you do addition and subtraction, what do you got to do for the sig figs? You got to line them up. 10.45 minus 10.23. And you got to get an answer. What's our answer there? What's that? 10.22? 0.22? 0.22. Our sig figs stop right there. So we have that we can move forward with now. 0.22 divided by 0.6531. When you do division, it's just the smallest number. So the answer here is 2. How many sig figs? 2. Okay? Addition and subtraction has to be lined up like that. All right. Do we have another one here? How many grams of ammonia will result if 10 grams of nitrogen is reacted with 1.7 grams of hydrogen? Ruminate on that for a while. See if you can figure it out. Hi. I just raised that question. That was a good question. Okay, did you get an answer? Okay, how many grams of ammonia will result if 10 grams of nitrogen react with 1.7 grams of hydrogen? Anybody get an answer? Do we know what to do here? How do we set this up? No? So we're looking for what at the right of the equal sign? Grams of ammonia. What's ammonia? NH3. NH3 is ammonia. NH4 is the ammonium ion. So we got NH3. Good. Now what? What can we start with? $1.7 grams of hydrogen. How did you know not to start with the 10 grams of nitrogen? Or maybe we have to start with the 10 grams of nitrogen also. Is that true? How do we know? What kind of a reaction is it, or a problem is this? Yeah, it's a limiting reagent problem. When you're told information about two amounts of the reactants, two amounts of two different reactants, right? Then you're going to be needing to solve for the answer twice. So, 10 grams of nitrogen gas, 1.7 grams of hydrogen gas. You guys want a few seconds to work on it there, or should I continue? Want to try for a little bit? Okay. What's the percent composition of octanol?
According to anodes.com.
All right, did we get it? Did anybody calculate how many grams of ammonia we would get from 1.7 grams of hydrogen? We got to go grams of hydrogen to what? Moles of hydrogen, H2. And then we got to go moles of H2 to what? Moles of ammonia, NH3. And then moles of ammonia, NH3 to grams of ammonia. I know this one, 14, 15, 16, 17 grams for every 1 mole, right? I know this one, 2 grams for every 1 mole. Hydrogen gas, H2. NH3. Here, this one? This is NH3. This is H2. H2. Each hydrogen is 1.0079, so that times 2 is about 2.016. Okay, so where do we get this information though? Yeah, we have to find the equation. What happens when hydrogen gas combines with nitrogen gas to form ammonia? How do we balance that equation? 2 there, is that it? 2 times 3 is 6. Well, I think we need a 3 here, right? 3 hydrogens, 6, 3 times 2 is 6, 6 there, 2 nitrogens, 2 nitrogens. Okay, so what does that mean? 3 to 1? No, 3 to 2. 3 to 2. True? Okay. So, did anybody get a value here? 9.6. 10 grams of nitrogen. Grams of nitrogen, N2, to moles of nitrogen, N2. So that's what, 28? 28 grams for every 1 mole. And then moles of nitrogen to what? Moles of ammonia. And then moles of ammonia to grams of ammonia. 1 mole, 17 grams. What's this? N2 to NH3. 1 to 2? 2 ammonias for every 1 mole of nitrogen gas. So 10 times 2, 20 times 17 divided by 28.